Okay. And then also maybe I don't know. I think well, I'm actually planning to show you how Mathematica works, but hindi ko alam kung maging okay siya because it's not free. So I don't know if UP provides a license for that. So kahit i-demo ko siya sa inyo, because I like it because the way you write equations on paper is almost how you input it in Wolfram or in Mathematica. So even integrals of very complicated functions, madali siyang isolve via Mathematica. So yeah. Okay, I think recording had started. But before going on to your questions, maybe I'll just say a couple of words about the initial about the submissions. Because yeah, I started to grade some of them and some common problems or some common notions that I want to share with you, everyone, or some thoughts. Maybe, hold on, let me share my screen so you can follow what I'm saying. So homework one is due tonight, right before midnight. So, but again, you can submit after the deadline. Hindi na last time. So, but keep answering the homework. I think I allowed you to submit until the last day of classes. So I hope that's fine. Pero sana wag mag-pile up sa dulo, no? Kasi ako naman yung mga problema about pag-check ng mga papers. But anyway, I want to give you guys the luxury of time to struggle with these problems because again, what we want here is not for you to answer problems easily or in a heartbeat or quickly. I just want you to experience the struggle of mathematics. So hindi kasi instant yung pag-solve ng math problems. So it might take you some time, and it's fine with me as long as we meet the deadline for the semester. I mean, when I say the deadline, the university imposed deadlines because I will be very lenient with the deadlines. All right. So just a couple of things I want to share before I entertain questions from you guys. The first thing is that I hope this time you first well, math is a language, right? And when we talk about groups and fields, I would like you to forget for a moment the usual notion of operations or the usual symbols that you have learned or that you had been using since your elementary grades. Because here we are trying to generalize what we know for the set of real numbers that we had been using since our grade school. So ngayon, when you see the number 0 and the number 1, do not think of it as the usual number 0 and 1 that we know, because now I define the 0 and the 1 in the context of the course to be the additive identity or the 0 element, and 1 is the unity or the multiplicative identity. So whenever seeing this in any notation, unless I told you that these are the usual 0 and 1, then you cannot treat them that way. So they should be treated as symbols, placeholders for the additive identity and the multiplicative identity. And then in problem two, for instance, in the homework, let me just see if I can pull it up. Okay, there you go. Now we defined here. So problem 2 was phrased this way. So let R be a real number, so it is fixed, and S is another real number not equal to 0. Then we define addition and multiplication this way. Oops, this should be a comma. Plus C comma D equals A plus C comma B plus D. And then multiplication, oh, I guess I have a typo here. This should be, I should have used the symbol cross there. C comma T equals AC minus BD R squared plus S squared. So for those who didn't have any other courses on algebra or in linear algebra, so siguro I guess somebody told me na hindi sila familiar with the symbols or the use of symbols here. So the key here is that you read the problem and try to get rid of the usual notions of addition and multiplication na natutunan natin before. So here we're trying to extend everything that we had been using since elementary and try to unlearn everything, or at least forget for a moment those things that you know before in other courses, because here we are working with the assumption that you only know what was given in class or what was given in the prerequisite classes, the prerequisite classes for the class. So for instance here, let me just complete this one. So you just need to follow the definition. So if your set is R cross R, so you'll be the elements of your set would be ordered pairs. And then how do we do addition on ordered pairs? Of course, you might be thinking of the usual addition in Rn or in R2, right? That you know from, say, your algebra classes. And that's fine, because luckily that's how I define addition. It's just component-wise addition on R. The usual multiplication and vectors probably that you know would either be the cross product of two vectors from your calculus classes. That's another multiplication that can be defined on R squared. But insofar as problem number 2 is concerned, this is how I want you to do the multiplication. So if you have vector AB multiplied with vector CD, then it should be done this way. So the product would be AC minus BD times R squared plus S squared, comma, the second component will be given this one. Forget about all other multiplications that you know on R squared. All right? So I hope that's clear. So ganun yung babasahin yung problem. So forget about the other operations that you know before. Just stick to what was defined in the problem. All right? Any questions regarding that? Oh, guys, huwag kayong mahiyang magtanong, ha? Just keep those questions coming. I think I told you last time it's better to look so I don't care if some stupid questions with quotations. You might think your question is stupid, but it's valid for me. So questions?
Sir,
Okay,
nakasubmit ko na kasi yung number 2 ko, tapos may naalala akong hindi ko pala nasulat. Pwede i-add as comment?
Okay. So, yeah, just send me an email with the subject addendum to homework ganyan. So, yeah. So I guess as long as I haven't graded or rated your paper,
Ayun, hindi pa po na-checkan yun.
Sige, sir.
Alright. So, paki-email na lang. Okay, other questions? Wala? All right, so, and then the other thing I want to mention is, okay, right, more on symbols. So I guess some of you say, I don't remember what problem it is, but you said that probably problem 1, and then in the multiplication defined as x sub c. So some of you said that a comma b inverse is equal to 1 over a. Perhaps they wrote a inverse, b inverse, and then wrote 1 over a comma 1 over b. All right. Now I know what your intentions are, and I know what you are driving at. But here, these are all symbols to me. If I will be reading it from an abstract algebra point of view, which, by the way, properly contains the notions of fields, all right? So these 3 things here are nothing more but symbols to me, and they all pertain to the same thing, and they don't have any meaning for me unless we say that 1 over a and 1 over b are rational numbers. Then I know they are fractions. But without the context of knowing that they are fractions, I read them as this is the multiplicative inverse of a comma d. So this is what is to be multiplied to a comma b in order to give me the multiplicative identity identity in that structure, right? This guy is different. This multiplicative inverse of B of A, comma the multiplicative inverse of B. So these two guys are not necessarily the same. They will coincide if the multiplication was defined component-wise, right? So magmamatch. Pero kapag hindi component-wise yung multiplication as defined in the problem, these two guys might be different because again, this one is the multiplicative inverse of the ordered pair A comma B. Meanwhile, this guy is the ordered pair with first component the multiplicative inverse of A on its own field, and this guy is the multiplicative inverse of B. Actually, these two guys might not exist. Anyway, A inverse and B inverse might not exist because we are not sure if A and B are coming from a field. So if we are sure that A and B comes from a field, then this would be an element of your F cross F. Pero otherwise, we don't know that that will happen. All right. And then this one, this is another notation for the second equation or the second expression. So another way of writing A inverse or the multiplicative inverse of A is 1 over A. And another way of writing B inverse is 1 over B. But 1 over A and 1 over B are not fractions. They are not necessarily fractions. So sa R o sa Q, understood natin na 1 over A and 1 over B are fractions. But from an abstract algebra point of view, where A and B are not necessarily numbers, so 1 over A and 1 over B means nothing except that they are the multiplicative inverses of A and B respectively. All right? So yun yung mahirap siguro for any course in abstract algebra. We need to get rid of our notion. We need to unlearn all those defaults that we learned from our previous courses, because the thing here is that we're trying to generalize everything. And as mathematicians, medyo may konting yabang ang mga mathematicians eh. We try to be as generic as possible in our theorems or in our results. If, say, my result holds for, say, a larger set, so why will I confine myself to everything that is tangible, right? So kung yung result ko mag-hold sa kahit anong field, bakit ko siya iprove pa lamang sa real numbers? So I want to make results that will hold for as large as a universe as possible. And I'm not just concerned with something that is useful. So kung iprove ko siya na totoo siya for any, say, quaternions or for any complex numbers, kahit wala siyang real life application, the mathematician inside of me would like to prove it anyway, because everything here is just a game. And I want to be as general as possible. Okay, so far? Wala pa naman? Okay, and then this might be a little bit controversial. Ano to no offense meant to anybody. About proving identities, and this is a common thing, and I hope you guys won't take it in a bad light or in a bad way. How do we prove identities? Well, I know from high school we have a certain way of proving identities. Say, maybe I should quote something from the homework. In particular, in the proof of was identity. So in that problem, I ask you to prove. Maybe I should use red. Okay. I ask you to prove that A minus ABA is equal to A inverse plus B inverse minus A quantity inverse. All right. Again, talking symbols here. What we are really trying to prove is that A minus ABA is the multiplicative inverse of this guy, of A inverse plus B inverse minus A to the inverse or inverse, right? So and then one way, I guess some of you got an easier proof than what I had in mind, because what I had in mind when writing the answer key is to manipulate this in order to get this one, or the other way around. But it is not until our first meeting last time that I realized, oh, it's an easier way. An easier way to prove it is to show that really this guy is the multiplicative inverse of A minus ABA, which some of you did. Good. Right. Now, in high school, I don't know kung ganun pa rin yung because it works, or at least from our point of view, it works. So usual notion that we do is to start with this identity and say multiply both sides by something, or perhaps it was in the other problem, or we add the common quantity to both sides, right? So parang ganon yung nangyayari.
Sir, naglalag po kayo.
Prove that that statement is correct. Sorry. Hold on. Yeah. Hello?
Yes, sir. So you were saying about proving equivalence in high school.
Yeah. Sorry about that. I just talked to my agent, my internet agent, para i-upgrade yung internet ko. But hopefully this would be good. All right. So I was talking about proving identities. Hold on, para mababa yung bandwidth ko. Okay, there you go. Yeah, just let me know if I keep on lagging in and out of the meeting. All right. So I was talking about proving identities. Let me see if I have a better example. Yeah, just to drive the point. Let me see. Yeah, I'm looking for an easier example. Okay. Let me do this. Negative ng negative A equals A. Okay? So, okay bang reception ko? Ang transmission ko? Okay, good. So, for instance, you are asked to prove this, okay? So, you want to prove that negative of negative A equals A. Of course, by now, I hope it's clear that what we are really trying to prove here is that A is the additive inverse of negative A, right? So, all you need to do is to add A to negative A to prove this statement, and then you're done, right? But siguro there are some habits that we learned early on that might keep on will keep on popping up on our minds, and we will be trying to use them. All right. So I hope you won't do this. So then you will start your proof this way. Okay, you start with a statement. And then I'll say, okay, I'll multiply both sides by -1. And then I'll get negative A equals negative A, and this is true. Lagyan nyo pa ng check sa ibabaw, and the proof. Yeah. Are you familiar with this scenario? Kasi ito yung naabutan ko nung nag-high school ako. Ganito namin ginagawa lalo na sa proof of trig identities. Have you guys have the same experience?
Sir, in trig identities, we normally start, but you can't, in proving equality kasi you can't manipulate both sides kasi you're not yet sure if they're equal. So you just have to manipulate one side first. And then make it show equivalent to the other side.
Yes. Yeah, the idea is to start with one side and then use some valid arguments in order to reach the other side, tama? But I guess this is something that I encountered back in high school. That pag meron ka halimbawa identity sa trig, so you start with that statement, multiply both sides or divide both sides by the same quantity, add the same quantity, and then come up with an identity in the end. Say 1 equals 1 or 0 equals 0. And actually, this is wrong. Sorry, from the logic point of view. Because here, I'm telling you to prove that this is true. And yet, you start the proof by assuming that this is true. So it's like that. In order to prove that someone is guilty, you'll stand in front of the court and say, "This guy is guilty because he is guilty." And if he's guilty, he did a crime. He did a crime, and that's an identity. So that means it is true. So I hope, of course, you are teachers. Some of you are teachers here. So I hope you stop presenting this as a proof, or teacher student the other a more formal way of doing the proof. This could be a nice analysis on how to do the proof, but this is not a logical proof, because again, you cannot start with what you want to prove as your first line in the proof, because it is using the statement to prove itself, which is not valid. All right. So yeah, I saw some submissions that has this kind of proof. I understand kasi lagi na lang whenever we're doing teacher training, laging merong questions about this, and then we try to correct them, and then argument arises. So yeah, I hope it's clear kung ano yung point ko dito. Though I'm not saying that this is totally wrong. It is logically wrong, but there is some value to it, because this will give you an idea of how to proceed with your proof. Okay. Questions, guys? Are you guys still there?
Listening, sir.
Yes po.
Okay. Na-disconnect ba ako?
Hindi po.
Okay, sure. Tahimik lang talaga kayo. Sorry. I just talked to my internet agent this morning, and yeah. Nagpapa-upgrade ako ng internet kasi sobrang choppy nga usually. But I hope that's clear. And I see the point why this doesn't make sense as a proof, because you cannot assume a statement in order to prove that it is correct, right? Though alam ko yung ginawa natin, ganun din yung ginawa ko nung high school. So, but actually you can translate that into a logically correct proof. Use the principle of modus tollens, or proof by contradiction. So probably what you can do is to assume otherwise. So ang sinasabi ko is, suppose you start the proof by suppose that negative of negative A is not equal to A. And it's valid because you are not assuming your statement to be true. You are actually assuming that if it's false, right? Oh, by the way, I used the dollar symbol for a supposition for the sake of contradiction. So here, I suppose that my statement is wrong for the sake of a contradiction to follow, right? So I assume that my statement is false. And then since this is not equal, if I multiply both sides by -1, then they should not be equal pa rin. Tama? So that means negative A must not be equal to negative A after I multiply both sides by a -1. And this is a contradiction because of the reflexive property of addition, of equality. So a number is always equal to itself. So it's a contradiction. So that means this initial supposition that I had, that they are not equal to each other, must be false. Because if that is false, then negative A will not be equal to itself. So you can conclude the negation of the assumption. So negative A of negative of negative A must be equal to A. End of proof. So parang ganun yung mangyayari. So para lang maitama yung ginagawa natin from high school. So kung magpo-prove ka na halimbawa, ano ba magandang identity? Parang sa trait. So assume that they are not equal. And then in the end, show that one is not equal to one, which is a big contradiction. So ganun yung mangyayari. All right? But I hope from now on, I won't see proofs like this in your submissions. So yeah. Okay?
Okay,
And
sir.
I hope you stop using teaching this kind of proof, all right? Kasi mahirap siyang i-unlearn, di ba? So, ako natutunan ko yan from high school. Tapos nag-work siya, I get perfect scores or near perfect scores nung high school. Ang hirap niyang bitawan pagdating sa college. Sa college naman, yung mga profs hindi papayag na, oh, tatamaan ko yan kasi yan yung natutunan niyo before. We need to correct them, all right? Okay. What's the other point I want to make before entertaining questions? Okay. Another thing, perhaps the last one from me. This is called the, I think I mentioned it last time, the meta-axiom of ignorance. Right. So this is one notion in any mathematical any mathematical discourse, right? So we only we only know what is explicitly assumed and what was previously proven. And this is in effect in any mathematical discourse. So we only know what is explicitly assumed and what was previously proven. So that means outside of those things, you cannot use them in any of your proofs. All right? So yun yung tinatawag na meta-axiom of ignorance in any mathematical discourse. That's why you will notice that for mathematics books, they have this chapter 0, which will try to introduce prerequisite topics. And then after that, starting in chapter 1, even the tiniest details were defined, even the smallest assumptions were explicitly mentioned, they are given, because in any logical discourse, you cannot go outside of that universe. So pwede nyo lang gamitin in our discussions, ano yung dinefine ko, ano yung axioms, ano yung previous assumptions na nakalagay dun sa course, and what are proven to be consequences of those assumptions and those things. So you cannot go beyond that. All right. Of course, we will assume that things that you know from high school, properties of real numbers, properties of complex numbers. That is fine. But outside of that, I will invoke the meta-axiom of ignorance. You cannot use them in this class. So, for instance, there's a nice proof. Somebody submitted a nice solution to problem 1. In problem 1, you have G is Z2 cross Z2. And this is basically, yeah. And it is known that Z2 cross Z2 is the unique field of order 4. So yung 0, 0 element niya can be renamed to be 0, to be the 0. 0, 1, I forgot what's the right one. This would be, is it x squared? 1, 1 is the unity. And then 1, 0 would be x plus 1, or the other way around. Hold on, let me fix this one. I need to make sure of the mapping. Sino nga ba yung nag-submit nito? Yeah, if somebody remembers the right labeling, you can let me know, but let me see. Okay, 1, 0 can be taken to be x, and then 0, 1 could be taken to be x plus 1. All right, okay. Yeah, so pwede mo daw i-assign si 0, 0, call it 0. 0, 1, call it x plus 1. 1, 0, call it x. And 1, 1, that's the unity. So that's the symbol 1, all right? So, so for instance, if you do what? If you do x plus 1, so you could add these two elements. So x plus 1 is equal to the sum of these two guys. So that will just be 0, comma 1. So you get x plus 1. So indeed, this is the right relabeling, right? And then he used this fact that, okay, now the Z2 cross Z2 I defined in the homework, along with its addition and multiplication, is isomorphic to to get to the Galois field of order 4, which is correct with elements 0, 1, x, and x plus 1. And since the Galois field is, of course, a field, then the field G defined on homework 1 will also be a field, right? And that argument is true because Galois theory will tell us that there is only a unique field of order 4, and that would be Z4, that is Z2, that is F4. You can give it any name you want, but it is known in algebra that there is only one field of order 4. So if you have a field of order 4, then it must be isomorphic, or it should have the same properties as that of Z4, at least from a structure point of view, all right? And that's fine, that is correct. But the problem there is in the course, we haven't defined what isomorphic means, or what does it take for a field to be isomorphic to another. Or we haven't established that there is only one field of order 4. I don't remember if I put it as a remark in the module, but the thing is we haven't established that fact. So, and then yung concept ng isomorphism, wala pa dito. You will learn that in modern algebra, but in linear algebra, that might be something at the back of my mind when I was trying to write the modules, but you cannot use that fact because we haven't established that in class. So meta-axiom of ignorance comes into play. You only know what we tacitly assumed, what we explicitly assumed, and what was previously proven. All right. So kung meron kayong gustong gamitin na result that was not given in class, then one remedy is to include that in your solution as a remark or as a lemma. And then try to include the proof of that just to convince me that that fact is correct. Because I'm operating under the assumption of ignorance that you don't know anything. You are blank slates coming into this class, except for things that we already know from high school or from elementary, how to add numbers, how to work with real numbers. But other than that, especially things from other graduate or undergraduate courses, they are not assumed to be true here. All right? Okay, I hope that is clear. And I hope I was not cut off again. All right. So now going to your questions. May mga tanong ba kayo, guys? About the modules, about the homework, or anything else?
Sir, dun sa vector po.
Okay, go ahead.
So do you have an example? I wanted to try to imagine it. You mentioned an example that v to the infinity where it is a. So hindi ko lang kasi ma-picture what like v vector to the n. More so v to the infinity looks like, or how do I need to picture it?
Mm-hmm. I guess I'm saying that would be the set of all sequences.
Apo, that's what apo. Infinite sequences?
Yeah, right.
Parang a set of containing the infinite sequences.
Mm-hmm. Right. Let me just take a look at where did I mention that exactly?
It's example. Answer.
Yeah, let me also look it up.
It's one of the examples po. Let me check.
Yeah. Mm-hmm. Okay. Yeah, I'll pull up.
Example 8, sir.
Example 8.
Apa.
Oh, that is in module 1 pa, no?
Module 1 pa lang po kami, sir.
Okay. Sa module 2 ko siya hinahanap. Module 1. Where is module 1? Module 1 should be somewhere here. Okay, there we go. Example 8.
Example 8 po.
Okay, let V be a vector space. The set V infinity of all infinite sequences is a vector space over R or over C. Okay, now perhaps let me copy this one and then let's discuss it in details. Okay, so perhaps let's look at a familiar example. So perhaps let's take V to be safe for R for a moment, just to understand the context of this example, right? So kung si V is ICR, we know that the set of real numbers is can be taken as a vector space over itself, right? Or in general, any field can be taken to be a vector space over itself. So V to the infinity will be the set of all sequences. And this is the usual sequences that you know from your calculus classes. So state ko lang siya in a certain way. So for instance, some elements of this vector space would be say 1, 2, 3, 4, and so on. So para siyang elements of R infinity. So it will just be an infinite listing of elements of R. So another example would be 0, 0, 0, and so on. All right. Or in a more familiar fashion, you can define your sequence this way. Though abuse of notation, I'm adopting a different notation here. You can say your sequence is 1 over n, which is the usual sequence that you know from high school. So this is or from calculus. So this would be the sequence whose first element is 1, corresponding to n equals 1. Second element is when n is equal to 2, you have 1/2. And then you get 1/3, you get 1/4, and so on. So these are the elements of R infinity. Any infinite sequence of infinite listing of real numbers will qualify as a sequence here. So parang siyang yung collection lang ng lahat ng posibleng sequences ng entries ay manggagaling kay R. And you can tie it up with the usual notion of sequences that you had in your Calculus 1 or Calculus 2 classes. So yun, ito yung mga vector space and sequences.
Okay, sir.
Right.
So
So if
is
it's
it
in
possible?
Rn,
So,
what do you think
pwede,
would be
sir,
the zero?
na... Sir? Hello?
Hello?
Sir?
Yes, hello?
Sir, kung V to the infinity, set of all... So, is there such thing as V raised to, let's say, 2? Would that mean 2
Yes.
vector?
Mm-hmm.
Would that mean 2 vector na only 2 elements with infinite sequences pa rin po?
When you say V2 or V upper 2,
Oh,
V
yes, sir.
squared,
Yes.
yeah, siya lang yung mga vectors na dalawa yung laman.
Ah,
so it's a
okay,
list
sir.
of 2
All right.
elements.
So, para siyang R to the N, in effect.
Yes. Mm-hmm.
All
Ito,
right.
mas general lang. Kasi yung R squared, isang example lang siya ng V squared. Kasi
nga.
any vector, V, can define a vector space this way. So
Alright.
para lang siyang R squared. So ito yung sinasabi ko na mayabang tayong mga mathematicians. So kahit sa tunay na buhay or in real world or in practice, ang nagagamit lang naman natin ay vectors of complex numbers at most. So
Opo.
C squared, C cubed, Z to the infinity, perhaps in some other applications. Pero kung ang structure naman nun, ang properties nun ay nag-work sa kahit anong imaginary vector, when I say imaginary, not in any reference to the imaginary number, but any made up vector space can generate other vector spaces by simply collecting them into a finite or an infinite listing of elements from the vector space. If you define addition as component-wise addition and scalar multiplication to be component-wise scalar multiplication, that will give you another vector space of the form b to the n or v to the infinity.
Okay, sir. Thank you po.
All right.
Sir, what about how does affine?
Affine spaces?
Yes, sir. Kasi hindi ko sure na intindihan yung ilalagay pa yung affine of the affine of X.
Okay. So when we hold on. Go back. Yeah, hopefully maalala ko yung definition. But anyway, we say that an affine
So you defined it in
did I call it the affine hull or the affine? It's not the space necessarily.
so you defined an affine combination and then you defined curl A X as the curly A of X as the
This is the set of all
affine combinations. Affine hull? You call it affine hull?
Oh yeah, the affine hull. Right, thank you. So this is the affine hull of a subset X of a vector space V, right? And it contains all linear combinations of the form alpha I, xi, going from 1 to n, but with a condition that the sum of the alpha i's must be equal to the unity. Tama?
Opo.
So, ibig sabihin, subset siya ng curly L of X. Kasi yung curly L of X, kinocontain niya lahat ng posibleng linear combinations. Tama? Pero kung nasa affine hull siya, linear combination pa rin siya, pero dapat yung scalars na nagge-generate doon sa linear combination na yon will sum up to 1.
To 1. Okay.
Mm-hmm.
So tama po ba? All vector spaces, you can actually rewrite it as a linear combination. Any vectors, if it's a vector, I can rewrite it as a linear combination of vectors. Tama po ba?
Yes.
In X.
But that will be discussed in module 2.
Ay, hindi sir, kasi nandito kasi siya sa module 1. You mentioned that a vector is a linear combination of vectors.
Yeah, that is vacuously true kasi kung meron akong vector x, pwede ko siyang isulat as 1 times x.
Opo.
And this one is a linear combination.
It's a combination. Okay. All right. Sige pa.
Yeah, which is alpha is equal to 1, n is equal to 1. Kasi yung isang vector, pwede ko siyang isulat na unity times itself.
Alright.
And this guy is a linear combination in itself, linear combination of a single element. So every vector is a linear combination. So ibig sabihin, si x ay element siya ng L big X if x is in X. And then, obviously, si x ay element din ng curly A of X if x is in A. X is in X. Tama? Kasi ibig sabihin, yung scalar na ipang-multiply ko dun sa linear combination of bawat term ng linear combination, ito lang naman yung linear combination niya. So, ibig sabihin, ang sum nito ay 1. So, ibig sabihin si x ay nasa curly A provided that x is in X is in X.
Okay.
So what are nice examples of this one? Well, yeah.
So, sir, what does it mean when you do apply now curly A of the curly A of X? Parang the hull of the hull?
Right. This one.
Yes.
Okay.
Why is it equal to just itself?
Nasa homework ba to? Wala naman.
Sir, wala po. Wala naman. Pero you boxed it and then you said it's one of the interesting...
yeah. This would be a nice... it would be a nice set theory or computational exercise. So let's try to prove it if you're game for it. So, ang affine hull daw ni X ay the same lang ng affine hull ni X. All right. So which one is easier? Because whenever proving equality of sets, we have to prove two things, right? So that one is a subset of the other and the other is a subset of the other one. And then we conclude using those two arguments that the two sets must be equal to each other, right?
Apo.
So let's try the first one. So we show that the affine hull is a subset of the affine of the affine hull. The affine hull of the affine hull of the set X. So usual proving of subsets. So you take one element of affine X. So we let say V be an element of curly AX. Then what does it mean when V is an element of AX? Then that means that V should be written as a linear combination of xi's going from 1 to n with xi in x and the sum of ai's should be equal to the unity, right? So definition lang ng pagiging nasa affine hulls. Pwede ko siyang isulat as a linear combination wherein the weights or the scalar weights has sum equal to the unity, right? So gusto kong ipakita na siya ay element ng affine hull. So here we want to show that there exist elements of the affine hull. Oh, actually, madali lang pala to. We want to find that there exists, say, some, let's call it yi, in the affine hull, such that si V ay pwede kong isulat as the linear combination ng mga yi's ay going from 1 to n, where the sum of the beta i's ay equal kay 1. Kasi ang target natin, mapakita that V, who belongs to the affine hull of X, also belongs to the affine of the affine hull of X. Tama? And in order for that to happen, I want to show that V can be written as a linear combination of elements of the affine hull. Kasi di ba pag nasa affine hull siya, dapat linear combination siya nung nasa loob ng set. Set na nasa loob ng affine hull. So ibig sabihin, if I want to show that V is in the affine hull of the affine hull of X, V should be written as a linear combination of elements of the affine hull with scalar weights summing up to the unity. So yun yung gusto kong gawin when I say this statement. Good so far?
Okay, sir.
All right. Clear ba yung notation? So yung kung bakit kailangan na yung mga vectors na ipapang-affine combination ko kay V ay manggaling dun sa affine X, sa curly AX.
Okay, sir.
All right. Now, can we find such an element? Paano ko isusulat si V in this manner? Do you agree that this will suffice? Okay, what's the implication of this statement here, or this conjunction here? That V is the unity times V, that's trivial, right? But V is in the affine hull by our assumption. So what does this statement tells us? So si V, pag tinignan ko siya as unity times V, alam ko si V nasa affine hull. Tapos ang sum ng scalar. Ano yung sum ng scalars na ginamit ko sa linear combination representation for V? Unity lang. So it sums up to unity, right? So what would be my conclusion here? Anyone?
So you expressed, sir, V as a linear combination of V, which is in the affine of X. And therefore, okay.
Therefore what?
Therefore, since parang this V, 1 times V, parang yan yung i-replace mo dun sa X. So, that V is actually the affine of the affine of X.
Right.
Tama, sir?
Actually, siguro pampagulo tong statement na to. Probably I could erase this part because hindi ko naman siya kailangan yung pagkaka-define ko kay X. But the idea here is, okay, nag-start ako sa V, element ng affine hull. Gusto kong ipakita na siya ay element ng affine hull ng affine hull. Right? But what does it take for an element of the vector space to belong to the affine hull of the affine hull? So that means this element V should be written as
a linear
combination nung mga
nandiyan.
nasa affine hull, tama?
Opo.
And the sum of the scalars must be equal to 1. Para maging affine combination siya ng mga nandun sa affine hull. But V has a trivial representation as a linear combination. And let's try if it will suffice. So si V, pwede ko siyang isulat as unity times itself. This one is a linear combination, though a trivial one, consisting only of one term, but nobody told us to use a certain number of addends in our linear combination, right? So isa tong valid linear representation. And look at the scalar. The scalar is 1. So that means this is an affine combination representation of V. Though a trivial one, but it will work, right? Pero ano sabi natin kay V? Si V ay nasa affine hull. So ibig sabihin, si V ay pwede kong isulat as an affine combination ng elements ng affine hull. So therefore, V
is an element of the
to the affine hull of X.
Okay.
So therefore,
so nakuha natin,
yung pabaliktad yung try natin kung madali. Actually, I haven't thought of it yet. Inimagine ko lang na madali siya. Kaya
parang sir, kukuha ka ulit naman ng linear combination. Magsa-start ka rin sa a V element of the affine of X.
Exactly.
And then how do you write it?
Yes. So para mangyayari ay I want to show that this, sorry pa iba na yung kulay ng ginagamit ko, but anyway. Okay, kukunin ko na yan. Ito yung gusto nating ipakita, right? The other way around. So that means we want to prove that a set is a subset of another set. So standard set theory technique, you get an element of this guy and show that that element is also in the set. Tama? So we let V be in the affine hull of X. And the target is to show that that V also belongs here.
There.
Right. So kung nag-scratch paper kayo or sa proofs nyo o sa scratch work nyo, pwedeng isulat nyo ano yung lahat ng posibleng implication from this statement. From this assumption, V is in the affine of the affine hull. What does it mean? So you always start with the definition. And I guess that's a habit that I have developed. So kung makikita nyo, sinulat ko kagad after my initial assumption in the first proof or the first part of the proof, sinulat ko kagad yung direct implication niya. But it turned out, hindi ko pala siya kailangan dun sa proof kasi mas madali yung proof than what I thought. But at least, it will guide my thought process. I know on paper what are the things that I already know about that set. And when I translate this into the actual proof, which I will submit to my professor or to a journal, I'll just remove all the unnecessary parts. But that's, I think this is a good habit. Try to write all things that you can get from a certain assumption, no matter how little they are, but they might figure out somewhere in the proof. So here, a direct consequence of being in the affine hull of the affine hull is that what? V can be written
as a linear combination
of
V. A linear combination of
linear combination of what? So yung mga VIs, kanino nang gagaling?
Doon na sa hull of X.
Right. This belongs to the hull of X. And what?
And alpha I, summation of alpha i's must be 1.
Must be equal to 1. Of course, we have the tacit assumption that the alpha i's are coming from the underlying field, right?
Left field.
But I guess that's understood from the context, which is fine. So this is what we know. But ano yung gusto kong ipakita? Perhaps pwede nyo ilagay dito, ano yung target para guided kayo, where do I want to take this argument to? So I want to show that V is a linear combination ng mga beta i's, right? X i's. But this time, gusto ko kasi mapakita nasa ano siya, nasa affine hull lang. So I want to show that this can be written where as a linear combination of xi's, but where will the xi come from so that I can conclude na element siya nito?
Xi should be an element of X.
Exactly. And then the sum of the beta i's must
Beta
be
i's
equal.
must be 1, where beta i's must be in F.
Right. So this is my target. And I will compare it with what I already have right now. So, okay. Oh, mukhang pwedeng yung mga alpha I from the direct consequence, maybe they can also work as the beta i's kasi sum nila ay 1, sum nila ay 1, so check na yung kalahati. But what's the requirement of those vectors in the summation? Well, the vi's, in our target, we want the xi's to come from X. But we already have some vectors, vi, but they come from alpha X. So, can we use those vi's para masatisfy yung target ko? Can I take the vi's to be my xi's? Medyo medyo mahirap isipin kapag
Ayun, sir, hindi ko ma-imagine eh.
Yes, sorry.
Sorry, sir, I couldn't just imagine kung Xi.
Kasi yun yung parang comparing what I know from what my target is, it looks like medyo magkamukha na sila, di ba? Yung alpha
Opo.
I, mukhang pwede siyang yung beta i's kasi ang sum naman ng mga alpha I ay 1. So mukhang pwede sila yung maging beta i's. But for that to happen, what should be the vectors in the combination? Ang meron ako, alam ko yung mga vectors dito ay nanggagaling kay convex hull, kay affine hull. Pero ano yung requirement dun sa target ko? The vectors should come from X. But does that tell you something? How about the others? Parang natahimik na yung iba. I hope this is making sense for everybody.
That V sub I is equal to the unity times X sub I for every I.
Yes, you can say that, but yeah. But actually, you can also say that but the convex hull, in the first place, is a subset of the big set X. Do you agree?
Big set X.
Yung affine hull ay nasa loob ng malaking set X.
Okay. Where X po is
Kasi,
parang puro vectors lang siya. Whose
puro vectors lang siya.
na linear combination niya, not necessarily the coefficient, the scalars are equal to 1. So, mas malaki si X. Okay, since tinatry ko pinipicture.
Yeah, and then si X laman niya yung affine hull. Kasi lahat ng elements ng affine hull ay pwede kong isulat, or actually they will belong to X. Kasi lahat ng element ni X, hindi, baliktad. Lahat ng element ng affine hull necessarily ay element din
ng
ni
X. Oh, okay.
Tama ba?
Opo.
Affine hull. Ang hirap isipin ng mga obvious, no?
Yun nga, sir. Actually, yung difficulty ko with the vectors is imagining which one is bigger and which one is smaller. So, para malaman ko kung nakalagay ba siya sa loob nun o nasa labas.
Let's try to picture it. So, meron kang vector space, V. Siyempre, siya yung pinakamalaki. Tapos, kukuha ko ng subset nung set na yun, ng vector space. Let's call it X. Tapos, kukunin ko, actually, baliktad pala. Tama ba? Baliktad? Kasi sure ako na lahat ng element ni X ay nasa affine hull.
Lahat?
Baligtad.
So ano po ba yung X? Di ba yung X is
It's just a subset of the
a
vectors.
vector space.
So because
So,
if I
pero sir, di ba
The
yung X,
generating set.
marami siyang, parang, hindi ba sir mas malaki si X? Ay, oo nga no. So, nasa loob niya yung, paano, nalito na ako.
So sure ako na lahat ng element ni X ay nasa affine hull. Kasi lahat ng element ni X, pwede kong isulat na 1 times X. Tapos ito, affine combination siya kasi yung sum ng scalars ay 1. But there could be some elements of this set which is not inside X but is inside the affine hull. So mas malaki yung affine hull.
Yes.
Yes, sir.
Right. So parang hindi mag-work yung iniisip kong argument.
Oo nga, sir.
Because for instance, kung medyo mahirap siya, you can give some specific it contains, say, one. Actually, magiging set containing 1 lang to. Kasi kahit anong fraction yung ilagay ko dun sa kabila, times 1, mag-sum up lang sila sa 1. Yeah. But anyway, the idea here, for instance, 2. So pag singleton, makukuha ko uli ay yung set X lang uli. If I'm working with the vector of real number, kung isa lang yung element ng set ko. Pero if I say 1 and 2, C1 ay element nung affine X kasi C1 pwede mo isulat na 1 times 1. C2 pwede rin kasi pwede ko siyang isulat na 1 times 2. Pero, can I find other elements, say, C 1/2 times 1, that's 1/2 times 2, which is equal to 1/2 plus 1, which is equal to 3/2. Element din siya ng affine hull. Kasi si 3/2 ay linear combination.
Pero sir, di ba i-add nyo na yung 1/2 saka
of the
1/2?
unity in R. Yes, 1/2 plus 1/2 is equal to 1.
To 1. So, yung 1, 2 kasi yun yung nandun sa X.
Yung 1 is in the affine, yet 3/2 doesn't belong to X. So definitely mas makita yung affine hull. Is that okay?
Mas malaki
Make
talaga.
sense? Yeah, mas malaki siya by just looking at this specific example. So I took a linear combination of elements of X. What are the elements of X? 1 and 2. I took one of their linear combinations, but I made sure that the sum of those coefficients is equal to 1. So I took 1/2 and 1/2. They sum up to 1. And so 3/2 is in the affine hull. So you can take other combinations. So 1 and 2, say 2/3 and 1/3. The scalars, 2/3 and 1/3, sum up to 1. And then this will give me 2/3 plus 2/3. So this will be 4/3. So this is also in the affine hull of X.
Okay, sir.
Okay? So mas malaki nga yung affine hull. So, kesa dun sa set X. So, with that, let's try to complete the proof before I try to address one of the questions in the chat. But anyway, okay. So, hindi pala siya pwede. So, so mas malaki. Oh, actually, so from what we analyzed, so now we know that
We know that A of X is bigger. X is a subset of AX. So sure tayo, sir, na nasa
right.
X na.
Aha, so ito ay nasa loob. So that means
Hindi tayo sure pa. Kasi there are elements of the affine
hold on.
that's not in X.
That are not in X. Exactly. So we need to be a little bit more creative here in showing that V can indeed be written as linear combinations of elements of X, whose scalar weights are sum up to 1. So let's see. Pero ito pala yung alam ko. Maybe I can manipulate this in order to get the sum of the beta i's and the xi's as well. Because all I know here is that the vi's come from the affine hull, but I don't know if elements of the affine hull
When
belong
multiplied
to
to
X.
alpha I. So alpha I.
Right. So ano kayong pwede kong gawin? So dito ako mag-work. How can I translate the VIs? Or perhaps I can do it this way. So what do I know? The VIs are coming from the convex hull. So what does being in the convex hull imply? So, okay. Hull. So that means each of the VIs can be written as an affine combinations of elements
Of B sub I, X I.
Of X sub I.
Right? So I can write it as say gamma of I times X sub,
okay.
actually I should do double indexing here.
Sir,
So,
hindi pa
ito
pwedeng
yung-
sir, can't we use B sub I na? Since, di ba, you let V equal to alpha, summation of alpha I times the summation of B sub I, X sub I. Hindi pwede. Dapat po
yeah,
ba?
but I need to be a little, I need to be a little that kasi yung mga VIs, alam ko na kay convex hull siya. So sa bawat I, meron ako makukuha ang linear combination ng mga elements ni X. So,
Okay.
maybe I should write that down here to make it for each I from 1 to n. Okay, there exists probably I'll call it X upper I, or maybe subscript na lang, just not to confuse it with exponentiation. So there exists Xij in X, and say let's call it gamma ij in F, such that Vi ay affine combination ng mga Xij na ito, j going from 1 to m, where the sum of the gamma ij's, j going from 1 to m, is equal to 1. Is that fair? I just applied the definition of being in the affine hull of X to each of the VIs.
Okay.
Good? All right. Now, I'll plug this in the sum for B. So I'll use it here. So remember, I have this guy. put that over here. Okay. And then I'll replace the VIs by this thing. All right. And then what's next?
Can you, sir, i-distribute yung alpha? So, pwede bang assume na yung multiplication ng alpha i's and yij would sum up to 1?
Right. So what you're suggesting is to write it this way. Ipapasok ko na yung
alpha I. So, both scalars. And then we just have to show that the two scalars multiplied to each other would sum up to 1.
Right. So what you want to show is that alpha I, gamma I, j going from 1 to m, the double sum should be equal to 1.
It's 1 times 1.
Right. And okay, but maybe before that, maybe I should copy this one. Without the grouping symbols. Okay. And probably say, so this will just be, I'll define it to be the summation of, say, just, so because I can treat this as a linear combination, double index lang ako, but I can expand it into a longer summation consisting of how many terms? Consisting of nm terms. Right?
Hello, sir?
Belong to the set X.
Oh, nawala po kayo.
Hello?
Okay. Okay, sir.
Hi. Hello? Am I back? All right. So, just removing the grouping symbol, tama? Because it's just a double summation,
Okay po.
right? And then now, if you imagine this, if you write it in a longer way, summation lang siya. Is that correct? Pwede ko tong isulat for each j. So, magkakaroon ako ng m na mga summation. So, m na mga mahabang summation along the j dimension. And then I will add all those long summations up on the index I. And so in the end, I will have a very long summation. Is that okay? Is that clear?
Okay po.
Okay. And then, so that means that we can write it as a single summation, right? I can write it as single long summation of the delta case times y case, where the delta case are of this form, parang nire-write ko lang siya in a single summation. And then the x sub ij's are my yks. Just a matter of re-indexing, rearranging the summation. But indeed, the double summation is just a longer single summation.
Okay.
Does that make sense?
Mm-hmm.
All right. So now my goal is we're halfway done because we know that the YKs are just the XIJs after some relabeling. And each of the XIJs are coming from this big set X. So what remains to be shown is that the summation of the deltas, which is just the double index summation of the alpha I gamma ij, should be equal to 1. Agree?
Opo.
Right. And then let's try to work it out. Now, double summation. I can, look at the alpha I. It doesn't depend on j, so I can factor it out. So I'll have I going from 1 to n, alpha I, j going from 1 to n, y gamma j. If you want to be strict about it, put parentheses there. Wala pa to. Yun yung I want to show that. I'll start the proof here.
And
Good?
then that's equal to 1. Okay.
Right. The sum of this sum is just equal to 1.
To 1.
And then this will just be the sum of alpha, since we are multiplying by the unity. And what is the sum of the alpha i's?
1.
That's just 1. So therefore, the sum of the double sum of the alpha or gammas, which is equal to the sum of the deltas, just sum up to 1. So this, guys, will qualify as coefficients for my affine combination. V, which can be written as sum of delta k's, yk's. The yk's, which are the xij's in this, guys, come from big X. And then the sum of the delta k's, which is just the double sum of alpha I, gamma I, j, sum up to 1. So therefore, this also belongs to the affine Hall of X. So that is, we have proven that the convex hull of the convex Hall of X is a subset of convex hull of X. So convex hull of the convex hull of X is equal to the convex hull of X. But I think I gave a remark that the convex hull is not necessarily a subspace of X. I guess it is only true when the zero element or the zero vector belongs to big X. All right, so yeah, those who need to go, thank you for coming. And then if you want, you can just watch the recording later. Hopefully in the recording, wala yung mga lags, yung mga napuputol. So also if I cut out, so I think I recorded it on my end. It's an interesting question. I think somebody asked in the chat earlier about the relationship between vector affine hull and the concept of convex hull geometry. Well, they are a little bit different. For one, convex hull nga siya. But there is a concept of affine hull in geometry. So siya yung kakambal ng convex hull in geometry. So the affine hull of, say, of your geometry follows the same thing. So meron kang, say, finite geometry or actually even an infinite geometry, say a projective geometry. So points on your geometry hull that we are talking about here. So encompassing talaga yung linear algebra, things like affine hull will pop up in geometry. Even later we'll also consider the convex hull probably, and that's very useful in doing optimization. So yeah. Okay, so I hope this gives you an idea not only about affine convex hull, but how to do proofs in general. So I think along the way we analyze it in details. What are the things that we can say and how to go about it, and yeah, and I think that's the beauty of doing things spontaneously. Kahit na matatagalan ka mag-isip in front of your class is involved in the thinking process. Of course, you can only do it if you have the luxury of time like what we have. But yeah, it's always a good thing to invite your students into your thought process and figure out these things step by step. Compared to I just having the proof beforehand and then just presenting it to you, I think this is a better way of doing things. But again, we sometimes are constrained by time. Okay.
Thank you, sir. Thank
Yeah.
you po.
Yep. Right. You're welcome. Any other questions? Yeah, just sa mga nag-submit since I think yesterday afternoon until right now. I'm seeing some submissions in the homework. Medyo mahaba na yung pila, so you might need to wait a little bit longer. So probably by tomorrow, I can give feedback to most of that because after our class, I'll need to review a journal article. Deadline ko rin ng submission ng review, so I'll be a little bit busy today. But I'll try to finish everything by tomorrow. And also, I'll upload module 3 because you are supposed to start with it by Monday. So yeah. Other concerns or questions?
So we have not started in module 2 yet.
Oh, with module 2. And module 2 should be... Oh, yeah, I see. So,
Kasi sir,
ano
we're
ba yung
just
module?
talking, kasi sir, what we're just discussing is just on module 1 still.
Oh, we should extend the timeline for module 1.
Oh, kung pwede sir, kasi
Yeah.
ito yung nagsa-start pa lang kami nagpo-prove, so.
Yeah, because I was initially thinking that, yeah, medyo familiar na kayo with fields and how to prove things in the abstract. So that's
Pero
why
hindi sir.
I thought compressing
Sir,
those two topics, fields and vector spaces,
nga po.
in
Sir,
one
kasi,
module.
opo, there are some of us, I think, sir, not yet really familiar with proving the way
Yeah.
you're doing it. Kasi some really didn't have it in the undergrad.
Oh, nice. So that's one problem
So,
that I did
yun nga
not
po.
foresee.
That's why, sir, if you notice, halos lahat ngayon lang nagsasubmit with the homework 1. Kasi parang we're just getting the hang of it. And then, due na actually, sir, by
Right.
Monday yung vectors. And then, tsaka pa lang kami, sir, makaka-start ng module 2 only after we've finished the homework on vectors. Yun lang, sir.
Yeah, and then after that you'll do homework 2 on vector spaces. Probably I should have compressed that into a single homework. But I was thinking na yeah, I a little bit foresaw that thing that medyo baka hindi kayo familiar about fields. That's why I included a homework on fields before going into vector spaces. And you see that that the homework problems for fields is a little bit not a little bit, but it's really
It's
involved
long.
computationally. Just to, as a refresher, but it turns out it's not just a refresher for some of you. It's a totally new thing for most of you. So I guess yun din yung kagandahan of including that here, so that yeah, this issues come up. But yeah, let's just adjust the timeline a little bit. I'll work on the syllabus and try to adjust it, just to give you more time to work with module 2. But I guess most of you have started submitting things for homework 1. So I guess you are a little bit done with module 1, but you might have not. Sorry. Yeah.
So just
module-
homework 1. Module 1 would include
first.
certain vector space, just the part 1 of module 1. So
Ay, oo
since
nga, no.
so may part 2 pa po tong module 1 yung. Ngayon pa lang, ito pa lang po yung dinidiscuss natin and we have 8 homeworks there. before pa po
Okay.
kami makakapunta sa module 2.
All right. So what I'm thinking would be, okay. Yeah, I'll move the deadline for homework 2 until when? Ano, open deadline naman tayo, di ba? So,
Kaya lang sir, di nyo na kami mabibigyan ng markup pag hindi nyo minove yung deadline.
yun nga eh, no? Habol yun talaga yung markup eh, no?
Sir, para po to cover.
Mag-ipon.
Mag-ipon sir, pag may mga mali kami.
Okay, so, all right. When was the supposed deadline for homework 2?
Sir, Monday na po.
It's on Monday?
Monday na sir.
Oh, but you said you just started with the second part of module 1.
Yes,
So,
sir.
yeah, perhaps let's move the deadline para dun sa mga markups nyo, no? Let's move it to Wednesday. Is that okay?
Okay, sir.
Yeah, let's move the deadline for deadline with quotes. Kasi open deadline naman tayo until the end of the semester. So let's move the deadline for the markups, the cutoff for the markups for homework 2 on Wednesday. And then I guess you can only start with, or you only start with the next module once you're done with the homework.
Yes, sir. Yes, sir.
Okay. Kasi ang iniisip ko ay nagagawa niyo siya simultaneously. That was
so,
my
hindi kaya so, hindi kaya ng utak.
Kaya medyo
parang sir, we couldn't move to the next module until parang we get to understand it better when we're able to do the homework. Doon pa lang po parang nagsisink in sa amin yung laman. So, we couldn't move on to the next, thinking what we have here, we should know before we go on to the next module. So, yun sir, in difficulty. So, if we move deadline by Wednesday, necessarily if you work on it, siguro sir, earliest we do start module 2 by Tuesday, Wednesday also, or Thursday na po for the others. So, module 2 pa lang, sir. So, sir, walang rush yung module 3 nyo. Kasi di pa po kami tapos.
Ang galing niya talaga makinegotiate, no?
Pwede ba yun, sir?
Right. Because I was thinking na you read module 1, part 1, then you start working with the homework. And then pag na-stuck kayo sa homework, sige, basahin ko muna yung module part 2.
So, hindi kami makamove on.
Hindi kami makamove on.
Hindi kayo makamove on ng merong nung may baggage pa.
Yes. So, kasi parang if you can't do the homework, ibig sabihin, hindi namin naintindihan yung laman nung module. That's why parang for us, yung assessment namin for ourselves to know that we've learned what it's there when we're able to answer the homework. So that's why we can't move to the next until we're officially done with one module. Sir, parang that's how I do it. I don't know with the rest. So I can't read module 2 without me answering all the homeworks first.
Habang nag-iisip ka pa ng module 1. No?
Oo, hindi sir kaya. Hindi sir kaya.
Kasi I mean, minsan kasi ganun yung ginagawa ko. I mean,
okay.
Meron akong inaaral, pero hindi ko siya totally gets or hindi ko masagutan. Nabasa ko na siya, hindi ko pa rin masagutan yung mga problems at the end. Just to keep, kasi parang hindi nag-work yung mind. Parang, I mean, kahit itry ko siya na sagutan ng sagutan, I get stuck somewhere and I don't know where to go. Ayoko magpanggap na mag-work pa rin ako doon, not being productive. So I'll try to do some other thing in the meantime. And hopefully when I come back with a fresh mind, magagawa ko na yung homework. But I guess that doesn't work for everyone. So, all right. So probably this is what we'll do. Let's move the deadline for homework 2 until Wednesday, at least for your markups, just to give you more time to work on it. I won't reduce the number of problems in homework 2 because I think they are much easier than homework 1. Kasi kung mapapansin nyo, all work 5 points each lang. So probably later I can give. Do you want me to give hints right away or probably next meeting na lang para nasimulan nyo na? You already
sir, dapat
started.
yun na ibigay. Kailangan nyo na ibigay yung hints, sir, para makatrabaho kami para the next time.
On kami, sir.
Para makamove on. So module 2 naman, sir, yung babasahin. Otherwise, sir, we wait again for the next before we can work on it again.
ayoko.
Okay. Sige, sir.
Okay.
So, yeah, the reason is I want you to try it first on your own without any idea of what my intended solution is para mag-struggle muna kayo para hindi ko ma-influence yung
Okay
thought
po.
process.
Alright.
Okay?
Sige po.
But let's schedule a meeting before the deadline so
Sige.
that by then you had struggled with it, medyo na-try nyo na siyang sagutan, but may mga tanong kayo, clarifications, you got stuck, you want some hints, I can give you some even way before the deadline. So I'm thinking let's meet again on Monday. Will that be good for you guys?
Okay, sir.
Around the same time? Or, around 11 probably on Monday?
Okay po.
Para ma-voice out nyo yung mga questions nyo about homework 2.
Alright po.
Does that seem fair? Does that sound fair to you?
Yes, sir.
Yes, sir.
How about the others? Okay.
Okay.
Okay, and then yeah, so that means I can only expect that you have finished module 1 completely by the deadline. At least kung meron kayong mga maiwan na problems, you can forget about it for the moment and then ipunin nyo na lang siya bago mag-end yung semester so that you can move on to module 2. And then I'll adjust the deadline for module 2 accordingly. I'll just take a look back again at module 2 and see how long it is or how deep it is so that I can know how much time you will need you need for it. And then, as you have said, hindi ko kailangang i-rush yung module 3, though I'm 2 theorems out of finishing module 3. Pipiliin ko na lang yung homework assignments at sasagutan sila para alam ko na kung ano yung level para hindi na ganun kahaba. But don't worry, future homeworks will just be at most 5 problems each. Kasi talagang intentionally ginawa ko mas mahaba yung homework 1 and homework 2 just to get a gauge of how you guys are doing. But and then these are just elementary topics. So when we come to future modules, this will be a little bit shorter, and probably I'll include some computational stuff for those who are more interested with computation, especially when we go to matrices. And I guess that will be easier for you because you're more familiar. But really, yeah, proving things in the abstract is always a different. It's always a different ball game. It's a different level, and that might be difficult, especially if this would be the first or second time you have seen it. All right. Okay. Aside from moving deadlines, any other concerns? I'll address Mary Joy. I'll
Hello.
address the question right before we end. Yes.
Hello, sir.
Hello, Jericho.
Hello, sir. This is not a concern, but can I have a request that for future sessions, can you please devote kahit mga 20 minutes of going through the material just to point out which are the things that are important? Kasi for us who are very new to abstract things, katulad ko na session ngayon, I really don't understand anything. Simula na about yung hall lang yung medyo naintindihan ko, but everything discussed today, I really don't understand anything. So if that's possible, can you please devote at least 15 or 20 minutes of going or scanning through the material just to point out these are the things that are important, these are the things that you should remember, because for me that's very new to this topic. I really wanted to have a grasp of things, at least the basic, yun man lang ma-master namin. Hindi na namin goal pa na makapunta for complex things eh. Kasi our goal is really to understand the concept, because if we understand these things, then we have the rest of our life understanding the complex things. I know you know what we're trying to, or what I'm saying here is, if we have a good foundation for the course, then I think that will be a very, very good springboard for us to understand the complex matters about the course. I understand this should be for graduate level, but yeah, yung 20 minutes or 15 minutes just to skim and scan the material and to just give us, these are important, this will be used for this one, and so on. Ayun lang, sir. Maliit na request.
Right. Yeah, thank you, Jericho, for pointing that out. Actually, yeah, I just want that suggestion to come from you guys, because yeah, I understand what you said and the intention behind it. Actually, I just wanted it to come from you guys, because the design, when this was offered to me by OU, they told me that this is a modular approach. It's purely asynchronous, so I don't want to impose something. So that's why I tried to make the modules as self-explanatory as possible, or as a properly contained material. But yeah, if you are new to this, even if you're not new to this, pag ginawa mo nga to sa face-to-face, it's very difficult. For instance, linear algebra in UP Diliman, from which they said this course is based, actually it's a hard and tough subject. Even if I have colleagues who took their masters in Diliman, took this course, and they really had a hard time. This is one of the hardest, probably, this one of the hardest subjects they said that they took in Diliman. So yeah, and doing it by just reading a set of modules, even if how good it is written or how verbose it was written, will not. I don't think will be enough. So thank you for pointing that out. I was just actually waiting for you guys to uh, to uh, to bring this up, because I was told that synchronous discussions is intentionally to be a tutorial session. I mean, if you have questions, I'll try to answer them, just like what we did with the convex hull. But it's a nice thing that the suggestion came from you. So yeah, I'll do that. Next meeting, probably we can devote probably not even 20. So probably about 30 minutes to 45 minutes to go through the material, probably present it the way I would have presented it in class. Not necessarily going through all the examples. Probably I'll just pick one or two just to illustrate the definition. And then the rest, probably if you have a good grasp of what the definition is or what the theorem is, then you can study on your own what those examples are for, right? And then you're right, you have the lifetime to figure things out or as you go along. Yeah, that's a good suggestion. We'll do that in our next meeting. And then towards the end, I'll give hints for homework too. Right. So don't hesitate to give your suggestions. I'll grant your suggestions. I'll flat out say no to your suggestion if I don't agree with it. So just bring them up. Yeah, there's no wala sa akin yung ganun. So pwede niyo siyang i-bring up anything that you want. All right? Other things?
Sir, question po.
Yes.
Kasi dito po sa homework 2, binabasa ko siya ngayon. Ang number 3 po, that's Q01. Q01 be the set of all continuous functions, right?
Uh-huh.
Ang number 3 po.
Number 3. Okay. Yeah. So yung C01.
Or
Yeah,
C yan,
C,
sir.
C.
Okay, C. So, complex numbers. Okay, sir. Akala ko kasi Q baka irrational. Ano nga yung rational.
Sir, hindi po siya complex numbers, right? It's just
Yeah,
annotation. Hindi siya complex. It's just annotation of the set.
Okay, sige, okay.
Yun yung usual notation for the set of all continuous functions over a set. So meron kang curly C. This could be another thing that is good to emphasize whenever we're doing live sessions.
Okay. Kasi akala ko kasi complex numbers.
Right. So yung curly C of those functions from 1 to R. So ang domain ng mga functions, so ang laman ni curly C ay mga functions so examples of functions that belong to curly C of 0, 1 ay sine of x. Kasi ang sine ay continuous, pero restricted yung domain sa open interval 0, 1. Another example would be your linear function f of x equals x. That's a linear function. It is continuous. It belongs to curly C. It's just that the domain is restricted to 0, 1. And then any polynomial belongs to curly C. What else? Cosine, sine, ang tangent. So, nasa ng asymptotes ng tangent? ang asymptotes ng tangent ay nasa multiple si pi over 2. Tama ba?
Pi over 2. Pi over 2.
Tama. So, nasa pi over 2. Anong pi over 2? 3.14 divided by 2. So, that's greater than 1. So, yung tangent ay magiging element din ng curly C. Even if you know the tangents in general are not continuous because they do have asymptotes at multiples of pi over 2 or odd multiples of pi over 2. Tama? Since curly C of 0, 1 is just a set of continuous functions on 0, 1, and wala namang asymptote si tangent sa open interval 0, 1, then ibig sabihin si tangent ay kasama dun sa curly C. Just to give you an idea of what if you go through the definition, well, you don't need specific examples. Pero para ma-visualize nyo lang yung curly C. All right? Does that answer your question?
Yes. Yes, sir.
Uh-huh. Yeah, if it still causes difficulty, then yeah, just let me know on our next meeting. So as we go, pero homework 2.
Tapos, sir, yung sa number 7, L yun. Kasi kasi baka iba yung mga notations na masusulat. Baka tapos baka iba yung meaning.
Okay. So sa number 7, yung curly L.
L, yes.
X. Yeah. So ito yung, if you remember, I think in part 1 of the module, we defined, no, it's in part 2 na pala.
Linear combinations.
We define curly L of X, the set of all linear
combinations. Okay.
Ng elements ni X. Yun yung notation for curly X. So yun pala, when you read the modules, you see to it that you also read through the examples because some of the notations or conventions are introduced in the examples. And once I use a certain notation, I'll use that for the entire course. So ganun ko siya ginagawa. So some of the examples will also be important. Okay. Wala na po? Wala na questions? Yeah, sorry pala if sometimes I cannot recognize you by your nickname, so it will sound a little bit formal. I'll just read what is highlighted on Teams. Yes, Mary Joy, what's your question?
Sir, yung about po sa reference materials para po for extra reading.
Okay, I'll answer you off the record. I-stop ko muna yung recording before I answer. Okay. Any other question? Wala na ba? So I can go to Mary Joy's question because I want to do it off the record. None? Ano pong ibang questions? So I'll stop recording here.